8.
Not that one there.
Okay, so we did a little intro to vectors, and hopefully getting familiar with drawing them tail to tip, tail to tip, and drawing the resulting vector. Today we want to go on and look at component and column vectors. Let's go through some of the theory part first. So, a unit vector is a new term we need to be aware of. A unit vector is a vector that has a length of 1, because unit, right? When it says unit, it means a length of 1. So it is a unit vector. Now, assuming that A cannot be equal to 0, if you're trying to find a unit vector, we have this lovely little symbol here. It's our vector A with a little arrow kind of pointing upwards. That symbol, the proper name for it is a U-hat, which I think is kind of fitting. U for unit. It means unit vector. Okay, and it's like a hat. Unit vector, the hat for a unit vector. Okay, anyway, that's how it makes sense to me. So when you see that symbol, it's talking about the unit vector A, and if I want to find the unit vector, I take my vector A, which could be of any length, I don't know what it is currently, but I would want to divide it by its length so that it was 1 unit long. And remember, our notation for length was looking like absolute values around that vector A. That means the length of A. So vector A divided by length of A gives us our unit vector. Okay? It also works for a negative vector. It's just a negative in front of the same thing, the vector A over the length of A, just in the opposite direction. Now, our vectors, we haven't been really giving them values yet so much, but they have, when we draw them, there's always an x component and a y component to represent the slope, right? Now, the distance that it goes, well, not the distance, sorry, but the unit vector along the x-axis, we're going to call that I, vector I. And it is the unit vector that begins at the point 0, 0 and travels to the point 1, 0. J is a unit vector that begins at 0, 0 and travels 1 unit on the y-axis. And you could draw a little diagram for that if it helps you to visualize it. Here's my little Cartesian plane, my x-axis and my y-axis. And if I start at the origin and I travel 1 space on my x-axis, that is going to be my unit vector I. You'll notice that we don't tend to put the hat on the unit vector I because that's understood that I is a unit vector. And going this way, if I go 1 space on the y-axis, that's going to be my unit vector J. Sorry, small.
Oh, okay.
I and J. And it's also important to note that I and J are perpendicular to each other. Okay, that's going to come in handy. Now we're going to be writing our vectors by their components. So consider a vector that begins at the origin 0, 0 and travels to a point P, which is x, y. The vector can be written in component form. So vector OP, we're used to that notation. It will be however far it goes along the x-axis times by the unit vector I, plus however far it travels along the y-axis times by the unit vector J. Yeah? So that's what's going to be called component form. You may also see vectors written as column vectors. So we could take the same example again. We have our vector beginning at the origin and traveling to the point P. So this time I can write my vector OP with either square brackets around it or round brackets around it. Doesn't really matter. I tend to use the square brackets. But you put the x component on the top and the y value on the bottom. Please don't write a fraction line though. It's not a fraction. It's just how far has it traveled along the x-axis for the top number and how far along the y-axis for the bottom number. It's not a divide, no. There is actually a third version, which you may read about if you like looking at extra things on the stuff they were doing, is that you can write your OP as an ordered pair. You could write it as x1, y1. You just write it as a normal bracket. And that hopefully totally makes sense, right? If we're starting at the origin and we're traveling out to some point P, then we could find the x value and the y value just by that point where P is. However, that is probably the most useful way if it is a position vector that starts from the origin, but as we know, not all vectors do start on the origin, which is why the other forms are more common in my mind. Isaac?
If we do it like that, when people think we're doing the same thing.
Yes, and it can be confusing, yes. That's the other problem with it. So hence why the other two forms I think are more useful and probably better ones to use, so you don't get yourself confused. Okay, all right. Next part, length and angle of a vector. Consider the vector u, which is shown on that diagram. So it's starting at the origin and it's traveling out through the point P. The length may be found using Pythagoras' theorem. The length of u squared is equal to x squared plus y squared, but I'll be honest, I don't tend to use that form very often. I prefer to simply square root straight away, so square root of x squared plus y squared. Okay, so if you want to find the length of your vector, you're just square rooting the x length plus x squared plus the y length squared. If you're trying to find the angle, now this angle you can see it's written on your diagram, theta. The side across from that is the length of y, and this side across here would be x, how far it's travelled along that x-axis. So if I was doing tan theta, which is opposite over adjacent, it would be the y over the x. Okay, so it's not really one that you need to remember. I think it's kind of intuitive. All right, I think that's it for theory. Let's do some questions. Yeah. I'm ignoring you. All right, question 1. A ship S leaves a port O and sails northeast at 15 kilometers per hour. Choose a convenient origin and axis, then describe its position after 5 hours by giving its position vector as a sum of the multiples of the base vectors I and j. They like to put all those words in there. It makes it sound super complicated, doesn't it? No, it doesn't sound so complicated? Oh, good. All right. Okay, it says to choose a convenient origin. I'm going to draw a little diagram. Yes. Obviously, the most convenient starting point to choose is the origin. So we're going to start here at O, the origin, and we are going to travel out to some point. It says sails northeast, so that tells me an angle, doesn't it? 45 degrees, so I'll try and make that look somewhat accurate. So I have a 45 degree angle in there, or you could draw it to the north if you'd like. Both of them would be 45, and that would be S. A ship S has left Port O and it's sailing northeast there. Now I'm not going to write that 15 kilometers per hour on there because it has given me a time that we're traveling for after 5 hours.
Is that an S or 5?
75.
Thank you. That's what you meant, I'm sure. So we actually want to know how far we've travelled along the x and how far we've travelled along the y. So a distance is going to be a more convenient measurement to use. So you can draw your little, and I'm sure you know this, speed equals distance over time. If I am trying to find my distance, I'm going to multiply my speed times my time. You know that diagram, don't you?
No, we've never seen that diagram.
No.
What?
We just do distance over time as if.
But then how do you rearrange it if you want something else?
Then you times it across and you rearrange it like
All right, let me explain to you how I explained to my year 8s in their last topic.
It makes so much sense.
To use that, you can work out any of the 3 things just by having that triangle. So if you,
What if you want S?
don't be smart. Okay, so if you want to know the distance, you put your finger over the D and then the S and the T are next to each other, so it's speed times time. If you want to know time, you put your finger over the T and it's distance over speed. Okay, that's that simple. I know, mind blown, right? Because you guys would be very hard to rearrange that equation. No, I'm sure you could rearrange it just fine. Then draw your diagram bigger.
Can the erase not rearrange yet?
No, they can.
Oh,
But it's easier if they can just write their formula straight down. Okay, so my speed was 15 kilometers an hour, and we're traveling our time for 5 hours. So that is the 75 kilometers that you guys have already told me. So over here on my diagram, I'm going to put that on here. 75 kilometers. So I'm going to make this into a right angle triangle. I'm going to cut straight down there, right angle. And I need to know how far over here on my x-axis have I gone.
Plus 45.
Yep. And I'm also going to need... Oh, slow down. Just because you've done this before.
G equals 53. 0.033.
I also need to know how far we've gone on the y-axis, which would be the vertical length that I've drawn on there. So, starting with, let's do the x-axis first. I'm going to find the distance OX. If I do cos of 45, that would be my adjacent side, which is OX, over 75. And then if I want to find the length of OX, then it's going to be 75 times cos 45. However, we are going to try and keep these exact.
75 over root 2.
Yes. So 45, cos of 45, if you remember from your exact value triangles, is 1 over root 2.
Yes.
So it's 75 over root 2, or rationalize.
75 root 2 over 2.
Yes. Okay, now if I was trying to find OY, the distance OY, because it's a 45-degree triangle, it's actually exactly the same, so isosceles. So I don't really need to go through all that working out again, right? So OY will also be 75 root 2 over 2.
Wouldn't it be 75 cos 45?
Yes, which
So
is
you
75
use
root
cos
2 over
a
2.
long way to get the right answer.
Anyway, to write my answer in component form, therefore OS was the vector that I was trying to write down in component form. OX, that distance, was 75 root 2 over 2 along the x-axis or unit vector I. And then the y direction was also 75 root 2 and a j. Yes. Okay, so that is it. We've done that question. We've written the vector OS in component form by finding how far along the x-axis it went, how far along the y-axis it went. That's
I
it.
keep on forgetting which way the J curves.
Crazy stuff.
That's the hard part for you. Anyway,
Yeah, actually, I did that as well. I draw it like an
Alright.
eye, then I cross it out.
Wait, miss, I didn't see this.
I can do it this
Sorry.
time,
In my
I like a
in my working out, I accidentally wrote J the wrong way.
and sometimes I forget to write like the little tilde underneath, and I gotta go back and put all the little tildes underneath.
That's a little
That's
the
a
little
tilde?
squiggle line underneath.
I thought it was just a line.
No, it's a wiggly line.
It's a bit.
It's
All right, moving on, people.
I'm gonna call it.
Question 2. Given that u equals 4 vector I minus 2j, I'm just going to say I and j, and v equals minus I plus 3j, find all those things there, 2u and 5v, and then 2u plus 5v. So one at a time, if I want to find 2 lots of vector u, you simply have to multiply 2, and u was equal to 4i minus 2j, and you can just multiply that through like normal. So 2 times 4 is 8i minus 2 times 2 is 4 vector j. So it's making that vector twice as long. Makes sense, doesn't it? Okay, so then it's going to be easy enough to do 5 vector v. We're going to be multiplying everything through by 5. So vector v was minus I plus 3j. So then just expand it through. So minus 5 lots of vector I and plus 15 vector j. And then finally, if you wanted to add 2u plus 5v. Okay, we've already worked out that 2u was 8i minus 4j. And then I want to add 5, except it's a minus, I'm going to change that sign to a minus 5i plus 15j. And you can just collect the like components. They're like terms, but they're components as well. So 8i minus 5i is 3i, and minus 4 plus 15 makes a positive 11j. What did we just do there? Let's have a look, because part B we actually did, and we could see what we've just done graphically. In B it says draw all 5 vectors as position vectors. What figure do the origin and heads of 2u, 5v, and 2u plus 5v form? So I suggest drawing this semi-accurately, otherwise it's very hard to know for sure what your shape is. Wait and see.
It could be a pentagon.
No, yeah, it'd be a dodecahedron.
You took the words out of my mouth.
To fit this in, if you're going to do it to scale, you need 15 spaces going on the y-axis, going up.
So
Be
I have
an
to draw
octagon.
15 lines. Oh. Okay, I'll do.
How many lines?
15.
Oh my goodness. Is that because we felt like it?
Wow, my scale is so accurate.
And how many do I need to go in that way?
No, we need it'd be 8, right? Oh, you'd need negatives as well.
Yes, I will need a few negatives.
Usually graph all the way to the side.
So I'm kind of only marking every 5. I think minus 5 is enough going that way. And I hope minus 5 is enough going down that way. All right. So the first vector that I had was 2u, which was 8i, so that's along the x-axis. I want to go 8 spaces along the x-axis, 5, 6, 7, 8. And then minus 4, which is down, 1, 2, 3, 4. Hopefully I can draw that nice and neatly about there. Might even use a ruler, because otherwise my line will probably be wobbly. So there is my vector for 2u. Okay, let's draw the next one, 5v. 5v was minus 5i, so over at minus 5 on the x-axis, and positive 15j, way up here. These are from the origin, remember? So that is 5v. And then 2u plus 5v was 3i, 1, 2, 3i, and 11j, which goes there.
That is a quadrilateral.
Really? Does it perhaps
Okay,
have
so it
four
says
sides?
parallelogram. If I were to add the 2u plus 5v, you would slide the 2u's coming out, and I would slide the 5v across like this, and it would end up coming up there. And that would be the equivalent vector on that side to add them tip to tail. Or you could have gone the other direction and moved the 2u up and gone 5v plus 2u going across the top. Either way you look at it, I've just made myself a parallelogram.
That's crazy stuff.
Crazy stuff. So therefore they form a parallelogram?
P-A-R. It's right there.
Okay,
Got 4 sides.
let's move on. Question 3. Given that this is in our column notation, column vector notation, given that u is 3, 1 and v is 1, 4, we want to find vector v minus vector u. Now you can just subtract them straight out of those brackets there. I want to do vector v, which is 1, 4, and I want to subtract vector u, which is 3, 1. That means, remember the top are the x values, just subtract the top. 1 take away 3 is negative 2. And then subtract the y's as well. 4 take away 1 is 3. And that would be my vector. Part B wants me to draw vector u as OU from the origin and vector v, OV as position vectors and mark where v take away u would be. So let's draw that. Everything's positive, so you finally can just fit it in the first quadrant.
For some reason, I thought 4 take 1 was 2.
That would be a problem.
It would be.
Okay, so starting with u, OU, the unit vector, is 3, 1. So we go out to 3 and we go up 1. And if we draw our vector line coming out, there is vector u. Then we want to draw vector v, which is 1, 4.
With that line, it doesn't curve or bend at all.
If I was going to subtract those two vectors, if I was going to do v take away u, you would be turning the u vector around the other way, correct? So you'd actually, I'll do it in a different color, it'd be like you're going that way, opposite direction, so minus u would be going in the other direction, and it would be starting here, and you'd be ending up there.
Wait, but isn't it a minus 2?
Yes, but I haven't started from the origin.
Oh.
I'm starting from, so the orange
V
line that
minus
I've
U
drawn
sine
there,
four.
if you look at it, my result was minus 2, 3. That means that from my starting dot there, I've gone 2 places to the left, and look, we've gone 2 spaces across to 1, and then I need to go 3 spaces up, which lands me at 4. So it does fit. But I'm just not starting from the origin. It was not a position vector. It wasn't starting at O. Okay? Yes, makes sense?
Yeah.
Good. Question 4. Yeah, you guys all right? Let A equal 3i minus 2j and B equals minus 4i plus 6j. Find lambda and mu so that lambda A plus mu B is equal to minus 4i minus j. There's a lot of letters in there, isn't there? Okay. So I need to find out, or I'm going to sub my vectors into that equation. So I've got, and I'm sorry, I should highlight, that's the equation there I'm going to sub them into. I'm going to put them into there. So I have a lambda, and instead of vector A, I'm going to put my components in there. I have 3i minus 2j, don't forget your tilde lines. And then I have plus mu, and vector B is minus 4i plus 6j. And that is going to be equal to minus 4i minus j. So you see what I've done? I've just subbed my vectors in so far. Now I'm going to expand through my brackets, which will look a little bit messy to begin with. It's going to be 3 lambda vector I minus 2 lambda vector j plus, oh actually no, not plus, sorry, minus because the 4, minus 4 mu I plus 6 mu j. And that's equal to minus 4i minus 4j. Okay, now this is where we're going to separate our components that are along the x-axis and our components along the y-axis. So looking at all the terms that have the unit vector I in them, I have got 3 lambda and I have a minus 4 mu. I'm equating the coefficients. So I'm taking the i's out of there. You're excited by this, are you? Okay. That's on the left-hand side. On the right-hand side, in front of my I have the number minus 4. So I'm taking all the coefficients. I'm saying, well, the coefficients of those ones on the left have to be equal to that minus 4 that's on the right. Yeah? Now let's do the same thing with our j's. On the left, I have a minus 2 lambda and a plus 6 mu. And on the right, that has to be equal to a negative 1. Okay, now I have to solve those to find lambda and mu, simultaneous equations. How about we times, what can I times by?
3 and 2 would be
Two and
easy.
three.
Alright, I'm going to times this one by 2, and I'm going to times this equation through by 3. Yeah, we're good so far?
Yep.
So let's times by 2. I get 6 lambda minus 8 mu is equal to negative 8. Timesing the 3 through, I get negative 6 lambda plus 18 mu equals minus 3. And now that I've made them both 6's in front of the lambda, I can add those two equations to make them cancel out. So minus 8 plus 18 is going to make 10 mu, and minus 8 plus a minus 3 will make negative 11. Yeah, unfortunately they're not nice numbers. Divide the 10 across to the other side. I get negative, you can times by negative, it'll still work. You'll get the same answer. You get negative 11 over 10. Yeah? I still need to get the lambda, so I have to sub back into one of my equations. Where shall we sub? How about just the top one there in red? So it would be 3 lambda minus 4 times by minus 11 over 10 is equal to negative 4. That's not so nice. All right, calculator time. I'm going to have minus 4, whoops, that again, minus 4 times negative 11 over 10.
Plus 4.
And if I move that across to the other side, I would have, maybe I'll just write it down first so I don't mess it up. That made 22 over 5 equals minus 4. So then I'm going to do minus 4, take that away. 3 lambda equals minus 42 over 5, and then divide the 3. Lambda equals minus 14 over 5. So I have found, I'll put a box around them because I was after the mu and I was after lambda.
Yeah, how'd you go from a minus 11? Oh, because it's a negative times negative, okay.
Yeah?
One of them.
So it's positive, it's just 3.
Alright, so there's a lot of minus signs and fractions in there, you just have to be careful. Calculation errors probably. Alright, question 5. Find the vector u of length 8 whose position vector has an angle of 120 degrees. So sometimes you have to be careful in this topic. If I say 120 degrees, that's going to be like my all stations to central, where I'm starting with the 0 being over here, and I'd be going anti-clockwise. So that 120 degrees would be somewhere out there like that. Okay, that's my vector u, which has a length of 8.
If it's on a line, what if it was like 90 degrees? Would it be sine? Oh wait, no. If it was 180 degrees, would it be sine or would it be tan? If it was on the line.
We do it from the graph if it's on the line. All right. So let's find the acute angle, which is going to be 60 degrees in here. Okay, so we are going to find how far along the x-axis we're going that way and how far along the y-axis that way. So we'll do x first. Using the 60 degrees, I'm going to go cos 60 equals x over the hypotenuse. Because I've got adjacent, I've got hypotenuse. So if I'm finding that length x,
wait, why are you doing cos? Should we be doing sine?
No, it's x.
I'm trying to find the x first. I'll get to I'll do sine, I'll do the y next, okay?
Yeah.
Cos 60 on half.
Cos 60 is a half, so I'm going to go, that's 8 times by cos 60, which means that's 8 times a half, and half of 8 is 4. That was the nice one. Now if I want to find y using the 60, I'm using the opposite and hypotenuse, and now we're going to use sine,
30. Oh, no,
still
no.
60,
Yeah, sorry.
is y over 8.
403.
Oh, okay, you're fast, let me do it. Y equals 8 times sine 60. Sine of 60 is root 3 over 2. Now, 8 divided by 2 makes 4 root 3. So if I want to write my vector u in component form, now be careful. The 4 that I found is the length, but what direction is it going? It is going, yes.
So it'd be
It is
negative
going to the
to
left.
negative 4.
So I need to put in that it's a negative 4i, and I have gone positive for the y direction though, so plus 4 root 3j. So remember, always be careful with your
How do you-
direction.
How do you know it's going that way?
Because of the 120 degrees, put it on that side, which meant it had to be going out to the
okay.
negative side.
Sorry.
Okay, and part B, find the length and angle to the nearest degree of vector v, which is minus I minus 3j. So this is a new vector. Let's draw it. It is at, when it says minus I, that means I want to go one space to the negative side and negative 3, so negative 3 down. And it's coming down here. Negative 1 and negative 3. I need to find the length and the angle. My angle will be in there. Now,
That should be
using our notation, I'll call this, I need to put on there, this is my vector v. Put that on there too. If I want to find the length of v, that's the correct notation for the length of v. And remember I said I prefer to just square root everything straight away, so it's Pythagoras' theorem, where I'm square rooting x, which is negative 1. You could just do 1 squared because the negative is kind of pointless, plus the y value, which is 3 squared. 1 squared is,
root 5.
no,
It's 10.
square root 10.
Which could put up to root 2, root 5.
How is that helpful?
It's not.
It's not. Okay. Then I want to find my angle. Remember, I found the length. The angle, we can use tan. If you need to draw your triangle on there, you could draw it up and go this opposite one here is 3, and that length there would be a 1, just the length. Don't worry about the minus sign. So if I want to find tan of theta, my opposite is 3, my adjacent is 1. And unfortunately, we can't do this one exactly. You would need to inverse tan 3, which is, you want me to tell you, don't you?
Do you want us to tell you it's 71.6?
Yeah, I'm gonna do the nearest
71.565
degree.
Actually.
So 72 degrees to the nearest degree. Okay, so that's we've answered the question. Therefore, our vector v has a length of root 10 at an angle of, now wait a second, the 72 degrees is obviously an angle, and I can read it off my diagram, but remember I probably should go back and write that in reference to my all stations to central. So I should go 180 plus the 72, which means that is
252.
252. Had me worried for a second there. That's it.